Hey, what's up everybody? It's Ms. Johnson again. I am back. I want to expand a little bit on something that I talked about in my very first video. If you have not seen that one, it's the one where I talk about the reason why we teach math the way that we teach math now. So if you haven't seen that one, stop this, go back to that one, and then come back here. So this is just going to be a quick video that explains to you what I mean by the difference between doing math and understanding math. Okay, old school, the way that we were taught, that was straight up just doing math and memorizing steps. Okay, if you were lucky enough to have a teacher that didn't make you memorize stuff and she actually taught to you about why everything worked the way that it worked, then you did learn the old school math. Okay, you were actually learning new math. There was conceptual understanding going on. So I'm going to show you an example. I'm going to use the long division algorithm to kind of hit home what I'm talking about the difference between doing math and understanding math. So let's do this real quick. I'm going to use the problem 365 divided by 7. So I'll tell you right now, this is a perfectly acceptable problem in the state of Texas for 4th grade. I'm not sure about the Common Core states and what grade levels you guys teach, what grade level you teach the standard algorithm for division. But this one, we're 4th grade. So we're talking about 8, 9-year-olds, 9, maybe 10-year-olds. And so this is an algorithm we straight up memorized, all of us. We straight up memorized it. Usually when I ask teachers why you line things up on the left, or not just teachers, anybody, when I ask them why you line things up on the left, crickets, okay? So I'll get to that when I get to the understanding part. So I'm just going to demonstrate the doing, all right? This is how we were taught. Lots of times this is taught with a little daddy, mother, sister, brother, okay? Kids are taught these steps. Daddy, mother, sister, brother. That means divide, multiply, subtract, bring down. So they're just repeating these steps over and over and over. So 4th graders are not comfortable with their 7s usually, okay? So before all of this happens, well, I'll get to that in a minute. Kiddos are not comfortable with their 7s, so this would pose a really big problem because they're going to go out to the side of their paper and have to figure out all their 7s all the time. And if you've ever looked at your kiddo and they have a bunch of work out here on the side of their paper like multiplication, it's because in the middle of doing a division problem, it's because they don't know their divisor, the factors. They don't know their 7s. So that's kind of, it just gets muddied up with all these different steps. We're talking about multiplying, dividing, multiplying, and subtracting. That's like 3 different operations all in one algorithm, all right? So this is how it's typically taught. We ask them, how many times does 7 go into 3? After some thinking, they'll go, it doesn't. Okay. So then we ask them to say, ask them to think, how many times will 7 go into 36? They probably don't know, so they'll go out to the side of their paper, figure out their 7s. Hopefully they're not drawing dots and circling groups of equal 7s and adding them up, because then they would be really, really far behind the game at that point. But I'll have some videos on that. So eventually they'll tell me what? 5, that it goes in there 5 times, all right? So the 5 written here is purposeful, but we usually just tell kids write it above the 6 because you were looking at the 36, so you're going to write it above here. I'll talk about why we put it there in the next example. So then we've done the division. Now we do the multiply. 5 times 7 is, and it's unbelievable how many kids will go out to the side of the paper and figure that out again because they didn't realize they just figured it out earlier in order to put 7 into 36. Okay, so that's the first red flag that will go up and say this kiddo is just memorizing and they don't truly understand what it is they're doing. Okay, so 5 times 7, we're doing the multiply, it's 35. But then all of a sudden, we go against everything we ever taught our kiddos from the time they started learning algorithms, which in Texas it's 2nd grade when they start learning standard algorithms. Now we're telling them to line it up on the left. What in the world? Why would you line it up on the left? Does anybody know? Okay, well, we're going to talk about it. Every once in a while, I will get somebody that knows why we line it up on the left. But it's few and far between. So anyways, we say, all right, 35. So now we're going to subtract 36 minus 35, and we get 1. And then we bring down, this is the brother part. Okay, so we did the division. How many times does 7 go into 36? We did that was the daddy. Now we do the mother, which is multiply. 5 times 7, we got 35. Then we did the subtract, which is sister. So then we get a 1, and then we bring down. That's the brother part. Daddy, mother, sister, brother. So the bring down is the 5. And we just bring that 5 down. We just drop it out of the sky, because that's what we like to do in math. Just bring things on down with no mathematical reasoning. Okay, so now we've got 15. And the kids are like, whoo, at least it ain't a big 3-digit number. So then we say, all right, kiddos, so how many times, we start the process back over, divide, multiply, subtract, bring down. How many times will 7 go into 15? And they're probably okay with this one. They'll say 2, all right? So then we go up and we write our 2, and we say, all right, multiply, the mommy part, 2 times 7, which was 14. Then we do the sister part, which is the subtract. 15 minus 14 is 1. And then we bring down. So this is where it differs between grade levels. Some grade levels will say, all right, once your remainder is less than your divisor, you're done. So we would have remainder 1. And actually in Texas, that is 4th grade. 4th grade will use a remainder and interpret what that remainder means. But then when you get to 5th grade, they will deal with 2 different things at the same time. And actually, there's a hole in our essays for that. And teachers usually don't even realize that you're supposed to go to a fraction here first before you get into decimals. So what happens is you ask your kids, how many times will 7 go into 1? And at first it appears that it doesn't. But if I just tweak the way that I say that, how much of this 7 does it take to make this 1? How much of a 7 does it take to make a 1? So if I have 7 of something, okay, if I have 7 and I just want 1, well, it's 1 out of how many? It's 1 out of 7. So that becomes a fraction. So instead of remainder 1 in 5th grade, they would take this to a fraction. So it would be 52 and 1/7. I think you guys can see that. So 52 and 1/7 is the answer to this. Then in 5th grade, then you could take this and turn it into a decimal, or then middle school, whatever grade level you are in Common Core. Then they'll take this and turn it into a decimal, or they'll do the decimal algorithm where they write the decimal and bring the 0 down, all that kind of stuff, okay? So, but that's fraction sense rather than just telling them, oh, take your remainder, write it over your divisor, then you're done. Well, we need to explain that to them, and that's how you do it, because this whole time we've been finding groups of. They didn't know that because we weren't saying that. So let me show you. That was straight up doing math, memorizing steps. Let me show you how to just tweak it a tad to get your kiddos to understand how to do this. Okay, understand why this algorithm works. All right. Same problem. 365 divided by 7. Now, I'm going to tell you right now, sorry, that's my dog. I'm going to tell you right now, shh, hush, hush. I'm going to tell you right now that I would do so much stuff before we ever got here. This would be the very last thing that I taught them, okay? I talked about that in the first video. Standard algorithms is the last thing because it's the most condensed. Okay, it's the least amount of steps to write, and we've got 9-year-olds on our hand. It's not okay for them to skip steps, okay? So we don't want them to skip steps. It's okay that they have to write out more steps. Eventually, we condense it down into those standard algorithms that all of us love so much. But then the standard algorithm, I swear to you, my 4th and 5th graders looked at me and they're like, Miss, why didn't you teach us this first? I'm like, because you wouldn't have understood it. Okay, so they didn't get that we had to draw it out and do all these partial quotients first before we naturally dwindled our way down into the standard algorithm. They naturally worked their way into this. And by this time, they weren't crying when we did the long division algorithm. They were so grateful. And they were like, Miss, you should have showed us this first. So, okay. But anyway, so let's do this. Let me show you how this is understanding math. I'm just tweaking it, still doing the same algorithm, just tweaking it a little bit. So instead of saying goes into, I'm actually going to revert back to talking about groups of. This is going to be extremely important, especially when they start getting into the multiplication and division with fractions, like 1/2 times 6. Thinking of that as a half a group of 6. It's so much easier for them to get the answer than having to go through an algorithm. So same thing here, I'm talking about equal groups of, because I want them to understand this inverse relationship between division and multiplication. So I'm going to say, all right, kiddos, so how many groups of 7 will it take to make 365? Is it going to take a lot of 7s, or is it going to take a little bit of 7s? And that gets them some reasonableness going on, okay? So then they start to think, okay, 7 and 7 and 7, wow, that's a lot of 7s. Even if I had 10 7s or 20 7s, they'll start thinking about how many 7s it's going to take, and they're going to go, you know what, it's going to take a lot of 7s, okay? So at least they've got some reasonableness going on, and they've already figured out this concept of division, all right? They're already thinking about it. So I asked them, how many times, or how many 7s will it take to go, how many 7s will it take to get into 3? All right, so I'm like doing that, it's weird because I don't even want to say that kind of standard algorithm way. How many 7s will go into 3? Because we said no earlier, but that's not really a 3. What is that? It's a 300. And doesn't 7 go into 300? It does. It goes a lot of times. So we lied to them. So when we said no, 7 doesn't go into 3, that wasn't true. The standard algorithm wants us to take off the biggest chunk as possible because then that keeps us from having to write a bunch of steps, okay? So that's the whole point, is to not have as many steps to write. So I'm going to go ahead and move on because the kids could figure this out so many other ways, but I'm going to go ahead and move on and just do that standard algorithm type of thing where we go on to this 36, okay? So when I ask them, all right, so how many 7s will it take to make 36? How many 7s will it take to make 36? And they'll tell me 5. All right, so I'm going to write this 5 up here at the top. And I said, why do we write the 5 there? Okay, does anybody know why we write the 5 there? Okay, so if this wasn't really a 3 and it was a 300, this isn't really a 36. What is it? It's a 360. So did it take 5 7s to make 360? No, it actually takes 50 7s to make 360. Somebody took this 0 off, okay? And for little kids, we want to put that 0 back on, okay? Eventually, you can take that 0 off once they get the idea of this whole place value and they're pulling the place value out and can understand it. Then they don't have to write that. When they truly understand that this 5 is sitting in the tens place, that's why it's written above the 6, and because it has a value of 50, then you can erase that 0. But until then, write it up there. It's okay. There's no math god anywhere that's going to come down and say, you cannot write it like that. And if some teacher thinks that they are the math god and they're going to say that, then that's not your fault, okay? So here, eventually they can take it off, but as elementary kiddos, we're writing the 0 there, okay? So now I can use compatible friendly numbers, use my number sense, and I can say, all right, so what did I say earlier? We said it took 5 groups of 7 to make 36 because that gave us a 35, right? It gave us a 35, got us really close. But that wasn't really 5 groups of 7, it was 50 groups of 7. So it's not really 35, okay? It's not 5 groups of 7, it's 50 groups of 7, which is not 35, it's 350. So it is not that you are writing 35 on the left and incorrectly lining up your place value. It's that you were writing 350 without this 0. Somebody took this 0 off simply because it was a shortcut. Stop with the shortcuts. Okay, that's the same thing when you're doing the standard algorithm for multiplication and you get the magical 0 out of nowhere land. That's that same 0 right there. Same 0. Stop. Put the 0 back. Kids never, ever, ever, ever have to take this 0 off. Okay, this 0 is not going to mess them up. All right, now they get, I figured out using compatible numbers how many groups of 7s it would take to get as close to 365 as possible using easy friendly numbers, and I'm going to go with 50. We decided to go with 50. 50 groups of 7 was 350. So man, I took a huge chunk off of this, okay? So when I finally subtract and I say, all right, I want to get rid of this 350, this chunk of 350, I'm now left with 15. I can subtract like normal. I'm not bringing anything down. Okay, do you see that? No bringing down. That's what that whole bringing down thing was. But why? No, there's no reason for that. Okay, so now I've taken off this big chunk. 50 groups of 7 was 350. I can take that off. 350, I can take it off. Now I have 15 left. I go through the same process. Okay, guys, we have 15 left over. I still need to figure out how many groups of 7, because we already figured out 50 groups of 7 to make this big chunk right here. So how many groups of 7 would it take to make 15? Kids should get that, and we'll say 2, it takes 2. So again, up here, we could then erase this 0 and write the 2 correctly in the place value spot. It's okay if you don't. You can write it like this. This is expanded notation. The kiddos are working on that when they're doing their place value unit anyways. It's not that big a deal, okay? It is not that big a deal. You could come out to the side and write all the partials out here. It doesn't matter. None of that matters. I don't want this to be a daddy, mother, sister, brother, do a little robot dance, and you're going to memorize all these steps. That's not what this is about. It's about the conversation of it, okay? So it's okay if you write +2. It's okay if you say, you know, I'm not really digging that. Kiddos, let's go ahead and erase that 0 because it's in our ones place and we have a 2 that needs to go in our ones place here. So then I say, kiddos, all right, so it was 2 more groups of 7. Well, what was that 2 groups of 7? Say it was 14. That's right. That's right. It was 14, so we can write our 14 here and we can take that chunk off. And then we're left with 1. And then the same conversation I had to you in the last example, the same conversation you would have here. Okay, so how much of this 7 would it take to make 1, so on and so forth. But just tweaking the way that we say it, and just putting a little bitty 0 in there, a couple of little zeros in there, totally changes the way that we view this algorithm, okay? We understand it now. This is understanding math and seeing the place value and the reason why the numbers work the way that they do, versus just doing daddy, mother, sister, brother, and memorizing a series of steps, and having to go out to the side of your paper and doing all kinds of extra work. And again, like I said, I would do a whole bunch of other stuff before this with partial quotients, to the point where the kids, they would probably even get this answer without having to write all this stuff down. So, but we will get there. That's another video. So I want to make this quick. I know it's kind of long, but you guys subscribe to my YouTube channel. It's Kristina Johnson. I am hard at work trying to get all these videos out for you guys, and I love all the requests that are coming in. So those are coming hot off the press. All right, see you guys later. Bye.